This wall sample contains moisture. One side resists vapor movement. So does the other. Can the moisture escape left, right, both, or neither? Pause and choose. Drying potential is an assembly's ability to release moisture under specific conditions. Drying may occur inward, outward, in both directions, or be strongly restricted. Drying potential depends on the complete assembly. Moisture can enter during construction, through rain leakage, capillary transport, air movement, or vapor diffusion. Finding restricted drying does not identify the original moisture source. A layer with greater diffusion resistance can reduce diffusion-based drying through that side. Its effect depends on thickness, declared performance, temperature, vapor conditions, adjoining materials, and continuity. Prediction test: if both sides strongly resist diffusion, what changes? Diffusion-based drying may become limited in both directions. This is sometimes informally called a vapor trap, but the phrase alone does not prove moisture damage. Why not call every such wall a failure? Because risk also depends on moisture entry, storage, material sensitivity, temperature, time, air leakage, and drying. One layer cannot define the whole moisture risk. Diffusion is only one transport mechanism. Bulk air can carry moisture through gaps. Rain can enter through exterior defects. Liquid water can move through contact and pores. A diffusion-only diagram cannot assess all these paths. Which wall dries better? You cannot know from these two membranes alone. Season, climate, indoor conditions, solar exposure, material storage, and the rest of the assembly may change the result. Insufficient information. Drying direction can also change. A wall may experience different temperature and vapor conditions across seasons, and some buildings can experience inward vapor drive. There is no universal direction for every assembly. Some variable permeance layers change diffusion resistance with environmental conditions. This may support drying in suitable designs, but it does not correct every moisture source or make every assembly appropriate. Variable permeance is not a universal fix. Assess 4 questions. Where could moisture enter? Where could it accumulate? Which drying paths remain available under expected conditions? And what do the applicable product data, requirements, and complete assembly analysis show? Final test. Wall A can dry mainly outward. Wall B can dry in both directions. Wall C has strong diffusion resistance on both sides. Which has a proven failure? None from this information alone.